Welcome to the What's New SOLIDWORKS 2012 webcast series. My name is Bill Mitchell, and I'll be doing the webcast for sheet metal, weldments, and drawings. So we got a handful of things to cover in this webcast, some new features in sheet metal, one thing in weldments, and then a couple of cool things in drawings. So let's go ahead and get started with this. And the first thing that we're going to cover in the sheet metal side is the new ability to cut across bins, meaning that you can have rather than have a through hole, you can actually have blind features that go across bin lines, and that allows it to get calculated with the flat pattern. Uh, there's a new feature within flat patterns that you can eliminate faces to show up during the flat pattern stage. There's some new functionality with edge flanges, some new abilities with forming tools, a new feature called swept flange, which works a lot like swept surfacing, and then a new utility for SOLIDWORKS Professional and Premium called SOLIDWORKS Costing. I'm going to touch on that a little bit, but we'll have another webcast in this series that actually goes more in depth with that functionality. So let's go ahead and jump over to SOLIDWORKS, and I will start a new file and start talking about the cut across bins feature. So the way that this works is if I come over and I'm just going to do a quick um, sheet metal part just to show you how it works. Let me switch my units real quick. I'm going to say that's maybe 4 by 2. Maybe make it a mid-plane extrusion, and I'll just create a simple right angle. And then the way that the cut across bins works is that you need to put the cut in the bin state. So um, which you come over into the sketch, and I'll just create a quick example. Say that's going to be 100 thou. All the lines have to be normal. And so you keep in mind that the functionality as far as the sheet metal stuff goes, needing to be planar values, those types of things are perpendicular and non-curved surfaces still applies so that it can still do the development at this point. But if I do a cut like this, and maybe make this a mid-plane extrusion, you should notice that notice how the cut goes across the bend. So if I go into my flattened sheet metal state, you can see now that that calculates that. It sees that that's a valid sheet metal flat pattern. Now, supposing I wanted to eliminate that, so whenever I do my sheet metal flat pattern, I don't necessarily want that pocket to exist because it's going to be maybe part of stamping or something that I would not want in my flat pattern for manufacturing reasons. If I come back in and edit my flat pattern feature, I've got a new box down here that says faces to exclude. So I've got my fixed face, so don't be confused about the face already highlighting. So the reason it's pre-highlighted is that's the fixed face for the flat pattern. But if I want to select the faces to eliminate or to eliminate during the flat pattern calculation, I can just come in here and select these guys, or select these faces, and say OK. So now when I flatten this, those faces are no longer available or no longer shown. So it eliminates the faces from being calculated during the flat pattern. So the new functionality basically is allowing you to do a blind cut like this across a bend, and then within the sheet metal feature, you can eliminate faces, or you can select faces to exclude when it does the flat pattern. So let me show you a little bit more of a complex example. This is from the demo set for 2012, and if you went to a rollout event, you may have seen this already, but this one's a little bit more complex. So with this sheet metal feature, let me come in and so kind of do a rollback just to see how they made this part. So first you have the right angle, very similar to what I just modeled. And then they did or created a boss extrude with the um, merge entities unchecked. So this basically makes this a separate solid body. That is, in my cut list, I've got 2 solid bodies now. And then they created an indent feature that basically displaces the material. If I come in and I hide this, you can see that it displaced the sheet metal material. Going in and looking at the sheet metal feature itself, you can see that that was the target body, that's the tool body region. It what faces to keep, and then I gave it a thickness. So for this to really work in actuality, you would want the thickness to equal um, the thickness of the sheet metal material. And then they went through and deleted the body, so you don't have that redundant body that might be throwing off your mass properties or something like that. And then they created some fillets to make it look as if it were a stamped piece. So now going into my flat pattern feature, if I try to flatten this, bring my dialog box over, it says this part contains features that cannot be undent. So what that's telling me is that it doesn't know how to handle this type of geometry. So in practice, what you're gonna, if you want to create features like this and have them be sheet metal parts, you can still create a flat pattern. So if I come back into my um, flat pattern feature, edit it, go to my faces to exclude, I can select these guys, and then coming back around, same thing on this side. So what I want to arrive at is looking for the faces that are inclusive of that indent feature. So now you can see that whenever it's in its flattened state, it actually works correctly. So it's almost like a suppress entities type of feature, to where it will suppress it during the flat pattern um, configuration. Keep in mind that as soon as I create a drawing of this, it's going to create a configuration for flat patterns. So it's almost like a suppress feature type of thing. So that's the new feature as far as cut across bins and flat patterns go. Let me close this out. I don't worry about saving either one of these. And then we'll talk a little bit about the new edge flange capabilities. So if I come over to my example file, come over to sheet metal, and then edge flange. Edge flange has got quite a few improvements over the last couple of releases, but the one that is in this release for SOLIDWORKS 2012 is the ability to use the tangent length, or to create the length based on a tangent bend. So I can say up to vertex. Let me jump out of this. And actually, to illustrate this with this particular file set, I need to have the assembly open. So I'm going to edit this in context. And if I come back into this part, edit it, I can go ahead and create my edge flange. I'm going to go normal to that face. Coming back into my sheet metal tools, edge flange, rotate this around just a little bit. So if I want to go up to vertex, so what I want to do is go up to the very edge of this part. Let me rotate this around just a little bit. So I want the end of that flange to always be coincident with the vertex of that front edge. But notice that if I start changing my angle value, come back to my, you can see that the calculation that it does, first it solves for the length, and then it starts to swing it down. So the length isn't really up to that vertex. It is relative to the z direction, but as it relates to my design intent is that I really want this edge to be flush with that mounting surface. So the way that you get around this, or the solution in 2012, is that I can say parallel to base flange. So that's going to come up to that point. And I've got some guide sketches down here. Notice as I go out, it keeps it all the way up. So I'll go ahead and say OK to that. And then as far as that's a little bit off it. Let me go ahead and modify this one more. I'll go ahead and create another edge flange. I'm selecting that. There we go. And again, coming back up to my length, say it's going to be 135. And now I can tell it for the length of my bend. I've got some new options down here. Tangent bend, so that it calculates based off the tangent. And then I can also say my length is tangent to bend. I want to inset my material. And you get, play with the different options here. But the new functionality is tangent to bend, so that basically the distance that I'm specifying is something that I can actually measure in with a fixture or caliper, so that it calculates it from the tangent point where the arc starts to the end of the member versus coming out to a theoretical intersection and then coming back up, saving you the time of having to calculate that out or create a construction geometry to reference a particular vertex or something like that. So that's the new stuff for edge flanges. Again, it's the ability to use. Come back over to my first edge flange to show you the option again. Parallel base flange, so that it always calculates the end of that vertex versus calculating the distance, and then using that to solve if I do, if I create an angle. And then the second feature is the ability to use the tangent length of the arc. So tangent to bend to calculate that. Okay, so the next thing to show you guys is the forming tools. So again, go ahead and jump out of that and open this up. Switch to an isometric view real quick. So coming in and talking about the forming tools, just a kind of quick refresher about how forming tools work. First of all, forming tools are part of your design library, and in order for the functionality to work, you need to right-click on your folders and make sure that you designate them as a forming tools folder. If you just drag and drop a part file, which essentially a forming tool is a part file with some special settings applied to it, but if you just drag and drop those out of the forming tools folder, it's going to ask you ask you if you want to create a derived configuration or derived part. So if I uncheck that, so notice that that's not checked. If I drag and drop this in, it asks me, are you trying to make a derived part? It's like, cancel out of that. So the reason that this works, or what makes it work, is the ability for it to recognize the forming tool features. So if I open this guy up, you can see that the forming tool feature has been applied. And to do that, you would just create your model and then create a forming tool. Whenever you do that, whenever you create the forming tool feature, it goes through, and this one's already got one applied, but it goes through and prompts you for some information about how a forming tool works, or the specified faces. So, and again, you can hit the help file for that if you need more information, or give us a call. But if you go to the forming tools folder, the new functionality within SOLIDWORKS 2012 is how this behaves. So whenever I drag and drop it, in previous releases, you kind of had to know the keystrokes to tab it. You hit tab to flip the sides back and forth, which side of the forming tool it was going to land on. But now within the menus, within the command manager, or the feature manager rather, you can flip those, you can rotate them directly in here without having to go in and rotate the sketch during placement. SOLIDWORKS 2012 also now supports configurations for your forming tools. So what that means is that you can create one forming tool with a lot of different configurations. If the only difference between forming tools, like in the instance of this louver, is that it's the length and height, things that you would typically control with a configuration, that's going to be supported in your forming tools now. Another option for forming tools is if you come down to link forming tool means that it's going to create a relationship, an in-context relationship to that forming tool file, so that if the forming tool ever changes, then the models change. And then also it has the ability to create a punch ID. This is stored within the forming tool folder or within the forming tool part itself. So I'll show you that in a moment. But to finish the placement of this thing, if I'll just go ahead and select the 100 millimeter by 15 by 10 wide. And it almost works like a hole wizard. So if I go to position, anywhere that I create a sketch point is where it's going to place these forming tools. So you can see now everywhere that I've put a sketch point, it's got a forming tool. If I come back and decide, oh, you know what, I made a mistake, I can say, 90. So all of them rotate together. So even if I don't get the placement right, I can always come back in, make a tweak. If I want to face the other way, whatever. Um, so that's the new functionality as far as placing forming tools. So I go ahead and say OK, and it finishes placing the forming tool. So if I come back over, if I want to swap that out, if I right click on this, I can replace forming tools. So this is almost like replacing a component in an assembly. So I can replace the forming tool with something else. So then it goes, looks for a forming tool. So you know what, I didn't want louvers, I really wanted a wire clip. It goes back through, say, okay, oops, okay, there it goes. Yeah, that was kind of weird. But in any event, it went through and created the wire clip. Now if I wanted to rotate that again, say, you know, I really wanted my wire clips to be horizontal. Oops, I think I did that wrong. Let me put this at 90. There we go. And maybe if I wanted them on the inside versus on the outside, I can always go back in and change that feature. So it's no longer as static as it was kind of in previous releases. You whatever you drag and drop from the design library, you had to delete and replace. Now there's a lot of flexibility as changing this thing out. With this particular wire clip, there's only one configuration. But again, if I want to change this out, let's go through this one more time. Say I really wanted to use a louver. Then come back in, edit the feature. Say that's going to be flip the tool, go ahead and point to whichever configuration I want. So there is the new functionality as far as the forming tool goes. Later on in the drawing section, I'm going to get into the punch tables, but just to show you while I'm here, um, the way that the punch tables work is that it pulls from a feature or from a file property called the punch ID. So in order to create that, if I open up my design library part, and then I come over to my file properties, drag this back over, there's a configuration specific property called punch ID. So what you're going to have to do is put it in the configuration specific area and then give it some value. It doesn't necessarily have to be a number. It can be whatever it is you want to show up on the punch table whenever you go to put it in your drawings. And again, I'll show that in a moment, but just to show you how you get to it is open up the punch or the forming tool rather, go to file properties, make sure that you're on the configuration specific tab, put in punch ID, whatever value you put in here is going to show up in the punch table. Okay, let's switch back over to PowerPoint and I'll show you so we can come back through this stuff. So the next thing I'm going to cover is swept flange. Swept flange, as I mentioned earlier in the webcast, is going to behave a lot like a swept surface. So the path can be open or closed. The path being the path, the profile that you create is how it's going to traverse. Um, the path is going to take, I guess. The start point of the path must lie on the plane of the profile. So you can't have a gap, and this again behaves a lot like a swept surface. One thing to consider is that any sharp corner is automatically filleted with the appropriate radii. It's going to pull that radius value from your sheet metal settings. So if you've got an 1/8 inch bend and you don't put any fillets in it, it's going to assume or it's going to automatically convert that sharp corner to a filleted corner. Um, as far as the go go through some of my notes here. The filleting is going to fail if it can't be made for round corners. So if you create a situation where the part becomes self-intersecting, again, a lot like a surface, it's not going to be able to create the flat pattern or do the development. Um, and then around corners and stuff, you don't really have to worry too much about creating your your swept or your fillets for it to create the appropriate sheet metal part. So if I come back over to my example file, um, come back out here, and I've got a path on this part already. You can see this part right here. I'll also go ahead and open it up by itself. So what I've got is a sketch that is related back to that assembly file, 300 millimeters. You can see it's just kind of a typical sketch path that you would have for a sweep. And then the profile is the channel that I'm going to sweep along. And notice that it is an open profile, so I don't have to have the closed profile of the extruded shape. This is making the assumption that everything is formed. One thing about the swept flange feature is that it's not automatically shown on the command manager. You can always go in and customize the command manager if it's something that you find that you're going to use frequently. You can come into your sheet metal tools, and then the sheet metal swept flange feature is going to, see if I can find it here, swept flange. So it looks like basically a extruded base flange with an orange swept flange icon across it. You can also get to it from the pull down menus, and the default behavior as of Service Pack 1 of 2012 anyway is if you go to sheet metal, you've got a new feature called swept flange, and you can always tell what the new features are, by the way. If there's a little blue question mark with asterisk by it by default, it shows you if there's something new about a given command for this release. So if I go into swept flange, um, again, the message says select an open sketch for the profile. So I'll select that, and then it asks me to select a path. Now, the path, again, can be a sketch, or it can be the edge of an existing um, sheet metal part. So for this example, I'm just going to select the sketch that's already predefined. You can see that it gives me a preview, and then some of the other features, you can flatten along the path, material inside, um, depending on which side you want the material to go into. Zoom in. So I can have the material inside or outside. I think for this particular sketch, it doesn't really have much of an effect. I can link it to a gauge table if I want to use an existing gauge table that I have. Sheet metal parameters allows me to designate the thickness, there it goes, which side it's going to be on, what my default bin radius is, if I want to have any auto relief, typical sheet metal type stuff. And so what this ends up giving me, if I zoom back out a little bit, is a form channel. So in previous releases, SOLIDWORKS 2011 and backwards, you would have a difficult time modeling this as a sheet metal part. You might have to go into maybe a multi-body sheet metal environment and try to do a lofted sheet metal piece or something along those lines. But in SOLIDWORKS 2012, you can see my flat pattern. That's odd. It should have flattened. So let's try this again. I think I had that setting incorrect. There we go. So you can see my flat pattern shows the bin lines. So those are my bin lines for, you can see the vertical ones are for the vertical bins. It still calculates a bounding box, and then it shows me the flatten for that swept bin for each step. So that's the new functionality as far as swept flanges go. It's a pretty cool feature. I think that they're going to probably build on it in other releases. But if you consult the help file on this feature, I'll go ahead and bring that up. Come back over here. So there are path requirements. You're going to want to read through this. Sketch set of curves must be joint CO, C0, and any sharp corners automatically filleted. So all the different criteria for making this work are listed in the help file. So if it's something that you're struggling with, you can certainly consult that, or give us a call if you have any questions on that one. And then the final thing as far as sheet metal goes is costing. So let me go ahead and close out of this and then open this guy up, something with a few features. Maybe I'll go ahead and put a couple more um, forming tools in here. So I'll go ahead and maybe make a couple of embosses just to populate this so we can see how the forming tool works or how the costing tool works. Delete this out. So I've got a couple little bosses. I'm going to hide this sketch just for clarity, and then some louvers. So again, SOLIDWORKS costing comes with SOLIDWORKS Professional and Premium. And whenever you have either one of those packages installed, you can come up to the command manager. It's in the sheet metal, and it also is from your tools. And then there's two different modes. And again, we're going to get into this a little bit more in a different webcast, but as it relates to the sheet metal stuff, you've got a sheet metal costing module and then a machining costing module. The requirement for the sheet metal costing module is basically that it needs to be a sheet metal feature. If you look in the feature manager on the left, you can see the first feature is a sheet metal part, or it's very similar to the way a weldment works. So that's what designates it or flags it as being capable of the sheet metal costing module. So if I launch that over on the right side in the task pane, you see that the sheet metal costing module comes up. You've got different templates. You can say whether it be in English or metric, and then you can get into the template editor, which I'll touch on. Let me just go ahead and launch it real quick and show you. Bring this back over here. Mine's set in read-only mode at the moment, but you can do within this, you can create what your currency mode is, whether it be in dollars or what your currency delimiter is. You can set up different setup costs and operations, um, what its distribution is, what its cost is, whether or not you always want to include it. You can set up all your materials and what categories they're listed in, any thicknesses. So if it's something that you're buying, common lot sizes, you can set all this up. The interface that you're looking at now is basically the out-of-the-box interface, so that you can customize this if you want. You can save that as a different template. And then as it relates to the sheet metal functionality, it's got three different ways that you can manufacture: water jet, plasma, laser, with its associated costs in terms of dollars, um, and then different cuts, whether it be punched, tapped, drilled, flow drilled, whatever information you wanted to put into this. And then as far as what the cut method is and the relative material, how thick it is, and what you want to charge per millimeter. So this is going to be like linear cuts or linear length. And the way that it calculates this, and once I get out of this interface, I'll show you, is that it takes the length of of all the cuts that that SOLIDWORKS calculates for your flat patterns. Different bend methods, whether it be just a straight bend, hem bend, and then per material, and then how you want to handle your library features. For example, like with a louver, setup cost is $20 per lot, and then anything custom, painting, anodizing, those types of things. So all the costing information gets put into this costing template. You apply the costing template, and then what it does is it goes and analyzes your model. So if I come back into costing, I'm going to just use the default template, select my material, what the material name is, what its thickness is. Notice that it flags it, so if my model is at 1 millimeter, it's like, well, if I've got something that's modeled, but I want to override that, I can say, well, I really want this to be 0.9 millimeters. It gives me my material cost. I can override that at this point if I want. Otherwise, it pulls it from the database. Bounding box. Again, if you come over to a SOLIDWORKS file, if you look at the file properties, file and then properties, some of the things about a sheet metal part. Let me jump out of this. Come back over here. Some of the things that SOLIDWORKS calculates about a sheet metal part. I'm sorry, it's in cut list properties. So if I come to my cut list properties, the bounding box length, width, area, cutting length, again, as it relates to the cutting cost, this is how it's grabbing that number. So whatever the value is, it's going to multiply that out, and that's how it calculates the cost. Um, so anyway, that's kind of where the data is coming from. So I tell it, do I want to use a flat pattern size, or if I want to do a bounding box or a custom sheet size, or even just a custom area, I'll just accept the defaults. I can always offset that a little bit. So if I'm gonna, if I want to account for the width of, how, depending on how detailed I really want to get, I can also preview that in the graphics area, so it shows me what my cut area is going to be or what my blank size is going to be. And then I can change this as far as total number of parts, what the lot size is. So right now my cost per part is 33 bucks. So if I say, well, I want to order that in lot sizes of, total number of parts, lot size is maybe 100. You can see that it updates it, or if I want to order 10,000 of them and my lot size is 500, see how much it costs. And again, this is all based off of, based off all the information that I put into the database. I can also apply a markup or a discount as a percent of total cost or percent of material cost. So as I do that, I can create a baseline. It goes through, flips around the model, does some analysis. Coming back over, so say, well, now I want to run a different scenario and say what happens if I make this out of aluminum instead. So you can see that the aluminum relative to my settings is quite a bit more expensive than the steel. So you can do different scenarios. This is a really quick way for you to get some costing and estimating information um, out of SolidWorks, and it's basically trying to meet that need as far as sheet metal places go. So basically, the intent is it automates the cost and estimation quotation process, includes your doing setup, cut paths, bins, includes library features, so you can include any costs associated with stamping, those types of things. Custom operations, lot size, material comparison, and then again, you can set the baseline to do an analysis on what if scenarios about how different ways to manufacture something, whether it be water jetted or lasered, or depending on the material and the design requirements as well. One final thing to show you on this one is over on the right side in the feature managers, you can see that for each one of these operations, it shows me how it calculated it. So my setup costs, kind of a breakdown per feature. It cost me $2 to cut it, and then all my setup costs. These are all my bin costs, and then it looks like the bulk of my cost is probably doing these louvers. And then if I wanted to do anything else that was um, custom, and then if the costing module can't find something, or if it's a feature that it doesn't understand in the model, then it says no cost assigned. And again, we're going to go more in depth with this, but this feature is available in SOLIDWORKS Professional and Premium, and that it will do costing for machine parts and sheet metal parts. So that's a pretty cool new utility. I'll go ahead and close out these files. And then the next thing to touch on, and I'll just mention it briefly, is the weldment stuff. In the weldments section, really the only new thing is how you create sub-weldments. If you save a sub-weldment body to a new part, then the cut list properties from the parent item get propagated to the sub-weldments. So actually, since I have a weldment here, I'll show you. Actually, I don't have this as in a weldment, so I'll just make a quick weldment file. something like this. Okay, so I've got a weldment, and now if the new functionality, notice if so I go ahead and assign a material, say that's going to be plain carbon steel, it updates the cut list and it shows me those items. So now if I wanted to do something special with this particular part, maybe it was going to be something that I subcontracted out, there was going to be some special operations assigned to it, I can go ahead and take that structural member, right click on it, insert into new part, and so everything that comes along with it, notice plain carbon steel came along with it. So that is the new functionality, is that all the metadata with the model comes. If I come over to my model, see that like my file properties or my material properties came along with it. And it also knows that it's a sheet metal part, or default is machine comes from, I shouldn't say sheet metal part, it knows that it's a weldment because it links back to that configuration. So it's a small change, but again, the weldment, the cut list properties come into new parts if I insert this into a new part. Okay, the last thing to cover for this webcast is what's new for drawings in 2012. There's some new features, align balloons, the balloons for your bombs with what are called magnetic lines, something that if users are familiar with 3D Via Composer is very familiar interface compared to that product. Automatically inserting center marks is covered. Bin tables and punch tables, we'll go ahead and cover that. Highlighting change dimensions and displaying hole wizard sizes, and then opening up assemblies and sub-assemblies from drawing views. So I'm going to kind of work this backwards um, from what I from the list. I'm going to go ahead and start with this file. Let this file open. So one of the things that you're going to notice with 2012 is if in previous releases, if I wanted to open up a component or a subassembly, I really couldn't open up the subassembly. I could either open up the component or right click and open up the assembly file that the view is selected or that the view is linked to. Now in 2012, I've got three icons. I can either open up this specific part, open up the subassembly, or the entire top level assembly. In this instance, I'll just open up the subassembly, and now I can make changes. So for example, if I want to change this particular part, I'll say it's going to, so I want to edit that sketch, didn't I? Maybe make this 75 or 80, say 80. So now that I've made a change to this part, if I go and open up the drawing that's associated with this file, what you're going to notice is that whenever you update a file or make a change, the next time that that file is opened, you're going to see that the dimensions are highlighted in whatever color you designate. In this particular file, I've said that I want my color to be red for changed dimensions. So if I mouse over this, you can see if I mouse over the value, and you've got to put your mouse cursor right on the dimension, it tells me what the current dimension is, but also tells me what the previous dimension is. This is going to make engineering changes and those types of things a lot easier, and it's also a lot easier to spot changes as they occur within a given drawing file set. If one of the changes also is that with the view palette, the automatic refresh isn't always pinging the file. So you've got this explicit control of whenever you do a refresh. This is going to help with opening file times and toggling back and forth between parts and assemblies. SOLIDWORKS 2011 and back, anytime that you came from an assembly file back into a drawing file, it was going to update the view palette, which would take time, especially if you had a really large assembly file. Another new addition is the addition of it automatically finding and adding exploded views if they're present in the assembly file. So if I right click or left click, drag and drop, it already knew that this assembly file had an exploded view associated with it. Now the exploded view does have to be present. It doesn't automatically do the explode for you, but if it does have the view, or does have the derived configuration rather, in the assembly file, it automatically makes that view in the view palette. I can right click rather than have to, if I want to change the explode state in previous releases, I would have to right click, go to properties, and then come back over and show an exploded state, toggle that on and off. Now I can just right click and say show an unexploded or show in exploded. So that is on the right click menu, which should help with toggling back and forth between those things. I can also now right click. If I go into my tables and create a bill of material, bill of material functionality has always been pretty strong with SOLIDWORKS. But if I come into my annotations and do my auto balloon, I've got a new option. Zoom into this real quick. I can follow the table order so that it will put the first item at the top. So depending on how the balloons are ordered, it's always going to, you can get a clean drawing rather than having to drag and drop this thing around, or even if you, having to hunt for the balloon item, it was kind of confusing if you had a really large assembly. Now you can, on a click, say, the first item in the list is going to be the first item in the bomb. Alternately, I can select the first item, say that that's going to be this piece is going to be the first item. Automatically shuffles it around for me. So that's a cool new feature with SOLIDWORKS 2012. You may have noticed that whenever I was selecting the items, I had a line. This is called a magnetic line. You can also insert a magnetic line here. What this allows me to do is in a group, pull all of my balloons around. I can create a new magnetic line. I can designate the length, what angle, how I want my spacing for the balloon. So if I want all my balloons equally spaced along that line, I would accept equal. And then I can just drag and drop these guys from one balloon line to the next. And then I can just at a glance or just pull all those balloons around. This makes relocating your balloons a lot easier too. So if you've got balloons that are kind of buried in a view, like this last one was, it's definitely going to help you out in relocating these guys. Again, drawing maybe another magnetic line up here. Then I'm going to attach some of these balloons to that magnetic line. You can also pull the length of the magnetic line around. So that's a cool new feature for putting in your balloons. One thing that is also new is if I come over to my whole table tab, you can see that if I select this, I can show the ANSI inch letter size. So if you're using, rather than call out the actual drill size, if I say show ANSI inch, those holes, A1, A2, and so on, are number 9 holes. Rather than having to know what the drill chart is, you can just include that information. It's smart enough to extract that information from the hole wizard feature and put that into your hole tables. We touched on earlier about the sheet metal functionality, so let me go ahead and open up a sheet metal part. Maybe just go back to that one that we were working on earlier. Come back into my sheet metal stuff, and I'll show you the I don't think I saved my changes on this, so let me go ahead and put some information in, kind of recreate what we did with that forming tool. Let me put these wire clips in as well. Okay, so if I make a drawing of this, got my flat pattern, so I'm going to go ahead and drag and drop this in. I'm going to change my sheet size just to make this a little bit easier to see. So now I've got my bins up and down and my punches. There's two new tables. So if I select my drawing view, insert tables, first one is going to be a bin table. So I'm going to grab that, select my view. And so now rather than having all the different information out here, I can just grab my fixed face, and then each one of these lines correlates to the bin table. So I can say tag A, B, C, D, what direction, what angle, what the radius is, and then that correlates to the tags over on the left side on the drawing view. The other type of table is the punch table. So grab that. I can select my punches. Since I'm already using ABC for my bins, I'll use 1, 2, 3. I'm going to tell it that my this is almost like a drill chart. So tell where 0, 0 is. Let me try that again. I think I forgot to select something. Okay, try this again. So if I come over to Insert, Tables, Punch Table, what I'd neglected to do was select Features. So come over, select the faces of the features that I want to include. There we go. So now that's the means by which it's going to pull those punch IDs that we outlined earlier in the webcast. And when I do this, it gives me a long list of punches, and I can come over here and maybe drag this view over just a little bit. And so it shows me, hide this sketch. There we go. So I have my different punch IDs, their angle, their XY location, punch ID. So this is how that information is coming from the configuration specific property. So those are the two new things as it relates to sheet metal parts, hole tables, or I'm sorry, bin table, punch table, and then again going back over to my PowerPoint slide, make sure that I covered everything. Aligning balloons, automatically inserting center marks. That was the last thing to cover. So if I come back over to SOLIDWORKS, if I don't have dimension lines put in, for example, delete this out of here, maybe delete some of these guys if something got forgotten, or I'll just delete them just to show it. What I can do is select my view, annotations, center mark, insert my center marks. Auto insert is the new feature. I can say for all holes, all fillets, or all slots. So in this instance, I'll say all holes. So that allows you to differentiate between how those are put in. It also lets me put in connection lines, circular planes, or circular lines rather. So this is going to be helpful if you forget to do it after the fact. Obviously, your system options are such that you can go through and change those, or your document properties, but you can also auto insert those after the fact, which will save you some time. A couple of other small settings, dimensions and labels, view labels. You've got two different areas, section and detail. Section view labels are going to be per standard. You can separate each one of those, the section name, label, scale. Each one of those can have a different font now. Detail view, auxiliary view. But the big change is that section view issue, changing how those work out. So anyway, that's what I've got for what's new for SOLIDWORKS 2012. As of this recording, the Service Pack 1 is available. Service Pack 2 should be out sometime in January, which is just right around the corner. But thanks a lot for watching.